One really distinctive characteristic of design is that idea of divergence and convergence. But there's another distinctive element of design, or distinctive characteristic of design processes, which is that they're fundamentally iterative. You'd like to believe that you could proceed sequentially from defining the problem, exploring alternatives, to selecting the solution. But the reality is that as you explore solutions, you get greater clarity about problem definition. And as you go to select an alternative or select a plan, you recognize some additional alternatives and maybe even get additional clarity around problem definition. In fact, I'm going to show you a little data here that illustrates one of the ways in which design is fundamentally iterative. This is some data collected by Gunther that takes the activities of a group of designers over a 2-hour period and divides them into 3 categories. These categories correspond roughly into our 3 steps in the design process: defining the problem or clarifying the task, exploring, searching for alternatives, and lastly, fixing the solution or selecting the plan. And what you see is that while there is this overarching cascading from clarifying the task to exploring alternatives to fixing the concept or selecting the approach, you do see this overall cascading. You also see a lot of back and forth. That is, it isn't the case that the team never revisits the clarification of the task after beginning to explore alternatives. And so design, even over a 2-hour period, ends up being quite iterative. And it's a bit of a misrepresentation to suggest that those 3 steps in the design process proceed strictly sequentially. Iteration in design takes place over many different timescales. There's the micro-level iteration that takes place at the hands of an individual designer, where he or she will go back and make changes, will try something else, will learn something and go back, and will iterate over minutes, hours, days, or weeks in the scope of a single project. But there's also iteration over multiple life cycles of an artifact that's produced by a single organization, or even over multiple generations of a category of artifact in society as a whole. So let me just walk you through a little bit of the history of the ice cream scoop. We started with last time with the fictitious notion that the first Egyptian commercial ice cream vendor, Tabia, had produced this block of wood with an iron scoop on it that had resulted in the first ice cream scoop. Now, of course, it didn't happen like that, but we don't know how it actually happened back in the 10th century. But imagine that Tabia, at the very micro level, had decided that the grip wasn't very comfortable and had said, well, gee, why don't we just cut a little scoop out of that so that the grip would be more comfortable. That's an example of iteration at the micro level, at the level of an individual designer. The first ice cream scoop that I know about that's commercially available is this one here. And the basic idea here was to take this conical metallic form, use it to mold a scoop of ice cream or potatoes or other kinds of semi-solid materials. And then there's this wing handle on the back that rotates a blade inside the cone that allows the formed food to drop out. At some point, this design emerged, which uses a hemispherical form to form the unit of the serving unit in the shape of a half of a ball, and then has this thumb action, this little rack and pinion and a little blade that separates the half ball from the mold. Now, in subsequent generations, like this one, the basic principle is quite similar. You see that the gear has moved to a different location, but the main advancement here is the adoption of lower cost production methods, in particular stamping and forming, in order to make these parts. Several generations of designs proceeded after that along the same basic idea, And most of the improvements relate to cost reduction, simplification, greater ergonomics. This one is die-cast aluminum, but has the same basic working principle. At some point, a scoop designer decided that that thumb action wasn't very ergonomic and that it would be much better to use the full grip. And so this is a design that relies on the full grip strength of the user, but still relies on the same blade action to cut the hemispherical unit out of the mold. At some point, some decades ago, someone concluded that there might be a way to use the warm scoop itself to prevent the sticking of the ice cream into the mold. And so this was a design, an all aluminum design. It's still quite common today, especially commercially, that relies on kind of a shaving action to form a curl of ice cream, and then relies on the idea that the large thermal mass of this aluminum would stay relatively warm and would allow the ball to separate from the mold. This design also has the idea if you shake it, you can sense that there's some liquid inside, and that's a heat transfer fluid of some kind. It might just be water, I don't know. Then the idea, at least the story goes, that the warmth from the user's hand actually is conducted into the end of the ice cream scoop in order to keep it warm and prevent it from sticking. But you'll see in many commercial establishments, these scoops will sit in a pan of warm water in order to keep them warm. The Xylus design in many ways builds on the success of this approach. It uses the large thermal mass of this aluminum head to reliably stay warmer than the ice cream, as long as it weren't stored in the freezer, and still uses that curved surface to create a curl of ice cream, but then the warmth of this head allows the ice cream to separate from the curved mold of the head itself. It also has a very ergonomic grip, which allows the operator's thumb to apply a downward force, which relieves some of the stress on the wrist. So that's just a short history of ice cream scoops in our case, since the 10th century, at least in our fictional narrative, but at least since the 19th century in the case of these early scoops. And what you see is that design creates great artifacts, not in one step, typically not as a result of the action of a single designer, but rather through successive generations of products, where each designer is able to rely on what's known based on prior generations of the artifact and to make improvements based on a foundation that's been established by others.